Okay, so let's knock out exponential equations. Very similarly, so when we're looking at exponential equations, we really want to kind of consider two strategies. Okay, so basically, can I rewrite the equation with like bases? So basically that means I can use the property a to the m equals a to the n. So if I have like bases, I can just say, m equals n. I can set the exponents equal to each other. So, if you had something like 2 squared is equal to 8 to the x. Since you can rewrite 8 with a base of 2, I could just say, 2 squared is equal to 8 is 2 cubed to the x. So this is 2 squared is equal to 2 to the 3x. And then you can just set the exponents equal to each other. So x would be equal to 2/3. So notice that domain of an exponential function is all real numbers. So it's not that you can't check this or that it's not a good idea, but you don't have the possibility of that no solution situation. Okay, the other strategy is when you don't have or can't manipulate like bases. So something like, we'll say no like bases. So let's say you had something like 2 squared is equal to 3 to the x, right? There's no way I can rewrite 3 with a base of 2. Well, in this case, I would just rewrite this as 4 is equal to 3x. What we do is we either take the common log or the natural log of both sides, and it doesn't matter which one you do. I commonly use natural log, but it doesn't matter. You'll get the same thing either way. So I would say, okay, natural log of 4 is equal to natural log of 3 to the x. And then what that enables us to do is to bring that x down as an exponent. So we have natural log of 4 is equal to x natural log of 3. And so x is equal to the natural log of 4 over the natural log of 3. And in ALEKS, it'll just tell you to leave your answer as an exact value in that form. And so that's it. So let's look at a couple examples of kind of the things that you'll be asked to do in ALEKS. All right, so let's take 64 to the 1 minus x is equal to 4 to the negative 6x. Okay, so I can manipulate like bases in this case. I can rewrite 64 as 4 to the 4th power. So I have 4 to the 4th to the 1 minus x is equal to 4 to the negative 6x. So again, I'm going to multiply the exponents here. Don't forget to distribute. So this would be 4 to the 4 minus 4x is equal to 4 to the negative 6x. Now I can set the exponents equal to each other. So 4 minus 4x is equal to negative 6x. So 4 is equal to adding 4. So what's 6 and negative 6 plus 4 is negative 2x. So x is equal to negative 2. So there we go. Okay, so next, let's take a look at one where you can't manipulate like bases. Okay, let's see. Let's look at 16 to the 8x is equal to 15 to the x minus 4. Okay, so can't manipulate like bases, so I'm just going to take natural log of both sides. Okay. Okay, so then what that does is, here I jumped the gun. Let me erase that. I'll do it in one fell swoop to show my work so it's not confusing. Okay, so natural log of that side, natural log of this side. So now we can bring those exponents down. So 8x natural log of 16 is equal to, don't forget to keep that exponent as one number, so put it in parentheses, natural log of 15. And so now I need to solve for x. So really, I think the easiest thing to do is, because I want to get x by itself, is first distribute natural log of 15. Remember, that's just a number. So I'm going to distribute it through the parentheses the same way I would if that was 2 times x minus 4. So this is 8x natural log of 16 equals x natural log of 15 minus 4 natural log of 15. So now, because I'm trying to solve for x, I want anything that has an x on one side and anything that doesn't on the other. So I'm going to take this x term to the left. So 8x natural log of 16 minus x natural log of 15 is equal to negative 4 natural log of 15. Okay, so take an x out, so that's how I can get it by itself. And then divide by everything but the x. So I'll have negative 4 natural log of 15 over 8 natural log of 16 minus natural log of 15. And again, you can just leave it like that. And again, it doesn't matter if you had used common log. I mean, you'll see that in ALEKS too. Like this, the same thing, if you plugged it into a calculator, you get the same decimal if it was like this. So that doesn't matter. So those two things mean the same thing. But that's basically it. Those are the two kinds of examples that you're going to see in ALEKS.